Experiment 5. Experiment 5. Right. The last experiment for the day from method of mixtures. Right? From method of mixtures, last one for the day. Right? Right. Write down determination of specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Specific latent heat of vaporization of water by method of mixtures. By method of mixtures. Right. So here also I can explain after materials and apparatus, right? But the thing is, again, the background is the, but the method is again simple, right? Mention materials and apparatus, right? Materials and apparatus. Materials and apparatus. Mention a calorimeter, a calorimeter, a calorimeter. A calorimeter, right? Then we have a special one here that is called steam generator, right? A. Next one, steam generator. Steam generator. Steam generator. Steam generator. Right. Then stirrer. Stirrer. Next, thermometer. Next, thermometer. Next, steam trap. Steam trap. Steam trap. Right. Next, heat insulated sheet. Heat insulated sheet. Heat insulated sheet. Right. Bunsen burner. Bunsen burner. Right. Then balance can අපි ආම්ම කුදලි වෙනානේ mesh එක ලිවෙත් නෑනේ. Then a wire mesh නැත්තම් a wire net, right? Wire mesh. A wire mesh. Right? 4-beam balance. Right? මේක නම් triple beam use කරන්නේ නැහැ because we are going to measure steam, right? It's a very small amount, very small mass, right? Triple beam එකෙන් අමාරුයි, right? It should be either 4-beam or chemical, right? Steam එකට measure කරන්න යන්න කොහොමද කරන්න කියලා කියන්න. Right? 4-beam balance slash chemical balance. 4-beam balance slash chemical balance. Right. Listen. Okay, this is the apparatus. This is called, listen, I'm going to explain while labeling this. This is called the steam generator, right? The steam generator, right? The literal meaning is this. Steam generator means when we burn this from the Bunsen burner, right? Inside this, we have water, right? And until this is reached, this is heated to the boiling point, steam generates, right? To take that steam as an output, this wire is put, this wire this tube is put, wire tube this tube is put. Steam now the generated heat can come along this tube to this one. This is called the steam trap. This is called the steam trap. Steam trap. Right? What happens here is when steam is coming from here to here. Now, what is the temperature of steam at here? 100. Right? That is at 100. Steam this is forming steam. Steam heat boiling water forming steam. That is at 100. But when it is reaching to this side through this tube, right? If the temperature decreases below 100, what happens? If the temperature of steam decreases below 100, because it is coming from here to here through this air medium, steam is at 100. What if temperature decreases below 100? What if temperature decreases below 100? Can there be steam at 99? No. Then what is there at 99? Water. Water has steam mega water, right? Then purpose of using steam trap is this, right? Steam trap and trap steam trap steam right? And some amount of steam can be converted to water again if there is cool down, right? Make a water not that water is falling down. Steam flowing on, steam is flowing and water is falling down, right? For this water to go out, this outlet is there. Water has not water right? And since steam is a gas, steam can gas it floats, right? It flows. This tube is put with the bend. Metan me bend එකක් තියෙනවා පේනවනේ. right? මම මේක මෙහෙම අන්දොත් නේ bend එකක් තියෙනවා. right? It is fixed with the bend. Then water is not going to go through this one because water falls down. Water එක මේකෙන් වැටෙනවා. මේක ඇතුලෙන් ආයෙ යන්න විදියක් නැහැ. Only the steam is going to go in and reach here. Right? ඒක තමයි steam trap කියන්නේ. If there are water forms, if there are water molecules forms, they are going to go out from this, right? Because our purpose is, if water has already formed, it should not be mixed with water here. Steam එක විතරක් මට mix කරගන්නයි ඕනේ. Only the steam should be mixed, right? Only the steam should be mixed. අර මෙතනින් මේ outlet එකෙන් water එක යනවා. steam එක මෙතන bend එකක් තියෙන එකයි bend එකක් නැතුව straight එකක් තිබ්බනම් water මෙතනින් එන්න පුළුවන් නේ. ඒකයි bend එකක් දාලා තියෙන්නේ. bend එකේ purpose එකක් සමහරලාට අහනවාද? Purpose of bend is to prevent water coming in through this tube, right? Only the steam comes through the bend, since that's a gas, right? And steam එක විතරක් මේක ඇතුළට එනවා, right? And this steam which is coming into the system is going to combine with water here, or going to mix with water here, right? Mix with water here, and it is going to do a state change. Water කියලා කියන්නේ දැන් 100 වල තියෙන එකෙක් නෙවෙයිනේ. Then it is going to do a state change. Then that steam should be converted to water at here inside the calorimeter, right? මෙතන convert වෙන එක මට වැඩක් නැහැ. ඉතින් අපිට වැඩක් නැහැ. Because that is out of the calculation, right? ඒකට තමයි මේ trap එක use කරන්නේ. නැත්තම් මේක මෙහෙම direct ගහලා දාන්න විදියක් නැහැ. trap එක ඕනේ නැහැ direct ගහලා කරන්න පුළුවන් නම්. එහෙම කරන්න බෑ. Because then some amount of steam will be converted into water when it is coming from here to here, right? ඒ part එක අර අපිට segregate කරන්න විදියක් නැහැ. We can't separate or segregate that part, right? That's why steam trap is used, right? Steam generator, purpose of steam generator is generating heat, right? Purpose of steam trap is segregating water and steam at this point, right? Then only steam is mixed here. හරිනේ? steam එක විතරක් mix වෙනවා. steam එක විතරක් mix වුණාට පස්සේ මෙන්න මේකයි. steam does this state change, right? For the state change, is it an absorption or liberation by steam? Steam මොකද කරන්නේ? Liberation or absorption? Steam to water නේ දැන් වෙන්නේ. Steam to water. Liberation. හරිනේ? Heat loss, liberation. Then liberated heat by steam. මෙන්න බලන්න logic එක. Liberated heat by steam. Right? Readings ටික ලියන්න ඉඩ දෙලා මම මෙහෙම ලියන්නම්. Then liberated heat by steam is equal to who is absorbing heat? Water and calorimeter. Right? Method එක simple, logic එක simple. Steam එකෙන් heat එක එනවා. Right? Heat එක යා liberate කරනවා. Steam liberates heat. Right? That liberated heat is absorbed by water and calorimeter here. Right? That is absorbed by water and calorimeter here. Then absorbed heat by water plus calorimeter. Right? Now, what are the readings we need? අර කලින් ඔය තමයි දැන් නිකන් logically හිතලා වුණා readings කියන්න පුළුවන්. I need the initial mass of calorimeter before order is added. Right? අර කලින් order එකම බලන්න මේ method of mixtures තුනම එකපාර පාඩම් කරන්න එක මම අන්තිමට කියන්නම්. Method of mixtures තුනම එක වගේ. They are very comparative. Right? When you study all three together. Right? එතන තුනක් තියෙනවනේ. තුනම එක වගේ. Right, first one, there are differences but there are more similarities. Right? First one, we need mass of empty. Mass of empty calorimeter with stirrer, same one. Right? Then mass of water calorimeter with stirrer, say M2. Right? What is the initial temperature of steam? 100, right? 100, right? මෙතනත් steam තියෙනවනේ. මේ steam එක 100 වල තියෙන්න ඕනේ because it was at 100 here. මෙතනින් ඔක්කොම ටික outlet එකෙන් යන්න, right? And to minimize that, from our side what we do is we are making this tube as short as possible here, right? මම මේකේ part එකක් ඇඳලා නැහැ මේක අඳින්න. Insulated sheet, right? අර කලින් කතාවම තමයි. Because if this gets a direct heat from this, again there is an error. Right? Mass of water calorimeter and stirrer මෙතනින් එනවා mass of water initial system එකේ mass of water කියන්නේ එතකොට M2 minus M1. Right? Then we need initial temperature of system කියන්නේ water, initial temperature of system. Right? Now during the process, does it increase heat or increase temperature or decrease temperature during the process here? Increasing or decreasing? Water. Does it increase or decrease heat? Decrease temperature? Increase. Because heat is added. Heat steam is added. Right? Steam at 100 is added. Right? And temperature then when it reaches the maximum temperature, final temperature of the system is a maximum temperature. Right? We need maximum temperature. Then maximum or final temperature of system, say 2. Right? Then finally, the final mass. Final mass, say M3. Then what is the mass of added steam? What is the mass of added steam? Mass of steam. M3 minus M2. Right? M3 minus M2. Right. This equation. Then, dimension liberated heat by steam. Right. Steam now steam at 100 comes in. Then first of all it should undergo the state change. Right? State change ml. Then mass of heat is steam is M3 minus M2. M3 minus M2 say L. Right? Plus now steam is converted into water. Now converted water by steam is at what's the temperature? 100. Is at 100. Then it should cool down from 100 to final temperature of water. Right? Ice එකේ වගේම තමයි. ඒ විදියමයි. හරිනේ? steam එක ආවා. steam එක water වලට convert වුණා. හැබැයි steam water වලට convert වෙච්ච ගමන් ඒක තියෙන්නේ 100 වල. Right? That amount of water is at 100. It should cool down to the final temperature. Right? එහෙනම් මෙයාට තව MSc එකක් මම ලියන්න ඕනේ. this same mass should be cooled down, right? Methane pass the water cool down from 100 to theta 2. 100 minus theta 2. 100 to theta 2, 100 minus theta 2 equals absorbed heat by water and calorimeter. Mass of water is m2 minus m1. m2 minus m1 Cw, right? Plus make a calorimeter m1 cs, right? What is the temperature difference for this system? Temperature increase theta 2 minus theta 1. Theta 2 minus theta 1. Theta 2 minus theta 1, right? Since everything else is known, L can be determined, right? Method of mixtures and especially latent heat of fusion of ice and latent heat of vaporization are also very comparative, right? Setup is different. Setup special things, but as a principle, as a concept, they are very much same, right? Logics okkoma same. Okay, apparatus right? Then take down the apparatus. Take down the apparatus. Right, make a label karagan thermometer. This is a glass tube. Make a this is a glass tube. This is a glass tube, right? Bunsen burner, tripod, right? Then steam trap, thermometer again, thermometer, right? This is called the bent tube, right? Calorimeter, right? This is outlet of water, right? Take down. Only the diagram. ටියුටේ තියෙන එක චෙක් කරත් කමක් නැහැ. මම ලේබල් කරලා තියෙන ටික හරියට බලලා දාගන්න. ෂීට් එක ලේබල් කරලා නැහැ නේ. ෂීට් එකත් ලේබල් කරනවා. Heat insulated sheet, right? මම මේක කලින් කිව්ව මොනවද හදන්න කියලා. Heat insulated sheet made of, it is either මොනවද කිව්වේ? Regiform or asbestos. කොහොමද? මේකද? ඔව්. හරි. එතනින් steam ගියාට ආයෙත් හොඳ question එකක්. Listen. That's a good question. Listen. Now, if steam goes out from this, right? That is very rare. ඒක rare වෙන්න reason එක මේක, right? Density of steam is less than density of air. Steam කියන එක උඩට යන්නේ. Density of steam is less than density of air, right? ඒ හින්දා මේ steam එක මේක through පහළට යන්න අමාරුයි. Right? It is rare, but even if it goes out, doesn't matter, because what I need is the collected mass of steam into this only. එළියට ගියත් අවුලක් නැහැ. එහෙම යන්නේ නැහැ. ගියත් අවුලක් නැහැ. මට මේකට ඇතුළට ආපු ටික විතරනේ මට මෙතන කැල්කියුලේෂන් එක ඕනේ. හරි? doesn't matter. doesn't matter. I haven't tried on the star. මේ ස්ටාර් එකක් ගන්න ඕනේ. sorry. හරි නේද? finish. Right. Then mention these readings first. After this, mention these readings. Mention these readings. Mass of empty calorimeter with stirrer. Mass of empty calorimeter with stirrer. මේක label කරලා නැහැ. This one. Wire gauze, wire mesh, or the square net. Square net. මෙතන තියෙනවා square net එක. Purpose එක මම කිව්වා. What's the purpose of using the square net? Right, and the label කරලා තිබෙනවා. What's the purpose of uniform distribution of heat throughout the bottom of steam generator now? Right, බාන මොනවා හරි මිස්සලා තියෙනද කියලා labels නෑ නේද? මිස්සලා තියෙනවා නම් කියන්න. නේද? Right, mention readings. First one. මේ හැම reading එකක්ම මම මේ හැම experiment එකෙම දුන්නේ that is in the correct order. ඒක තමයි sequence එක. ඒතර sequence එකත් එක්ක questions වල අහනවා. ඒතර sequence එකව දැනගෙන ඉන්න ඕනේ. Right, then first one, mass of empty calorimeter with stirrer M1. Second one, mass of water, comma calorimeter with stirrer. Mass of water, comma calorimeter with stirrer. M2. Right, next one, initial temperature of water. Initial temperature of water, theta 1. Right, next one, maximum/final temperature of water. Maximum/final temperature of water. Right, theta 2. Then final mass of system. Final mass of system M3. Right, ඊට පස්සේ ඉතින් අර තුන. Specific heat capacity of water CW. Specific heat capacity of water CW. Then specific heat capacity of calorimeter. CS. Right, next, specific latent heat of vaporization of water. Specific latent heat of vaporization of water. Right, L, capital L. right? Okay, right. अभी मेथड देख लिया, मैं केलिम कैलकुलेशन के मेंशन करो, right? Write down method, 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 method. First point, measure, measure, measure the mass of empty calorimeter with stirrer. Measure the mass of empty calorimeter with stirrer. Right. Next one, next point. Fill water up to 2/3. අර කලින් වගේම තමයි ඔබේ. Fill water up to 2/3. Fill water up to 2/3 of height of calorimeter. 2/3 of height of calorimeter. And measure the mass within brackets M2 and measure the mass within brackets M2 and initial temperature of water measure the mass M2 and initial temperature of water within brackets theta 1. Right, next point. Insert steam to calorimeter through steam trap. Insert steam to calorimeter through steam trap. And well stir the system. Well stir the system until temperature is increased significantly. And stop flow of steam right? Next point. Now in this one thing special. Now even though you stop steam right now, the temperature is not going to be stay unchanged right at this point, because there are steam that has already come into the calorimeter even though we have stopped from here. Right? ඒ ටිකත් mix වෙන්න දෙන්න ඕනේ. ඒතොර මෙතනට පස්සෙත් තව පොඩ්ඩක් temperature එක, even though this is disconnected, temperature of the calorimeter rises. right? මේකට ආපු steam ටිකක් තියෙනවනේ තාම. අපි මෙහෙන්න මේක දැන් ගලවන්නේ. right? මෙහෙන් ගලවන්න කියලා කියන්නේ දැන් මේක අයින් කරනවා. මේ trap එකෙන් මෙහෙම අයින් කරනවා. මෙහෙම trap එකෙන් අයින් කරාට මෙතන තියෙන steam එකක් තියෙනවා. ඒ steam එක තාම add වෙලා නැති, mix වෙලා නැති steam එකක් තියෙනවා. Then it is going to increase the temperature by a bit. right? ඒතොර ගලවපු ගමන් temperature එක අරගෙන හරියන්නේ නැහැ. You have to wait until it rises to the maximum point and have to take the reading at that particular point. Right? Next point. Wait until temperature of water rises to the maximum value, and take the final temperature within brackets theta 2, and take the final temperature within brackets theta 2. Right, next point. Measure the final mass of system. Measure the final mass of system. Measure the final mass. Measure the final mass of system M3 within brackets M3. Right, next point. Since there's no heat loss to environment, 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 put a comma and mention this. Liberated heat by steam equals absorbed heat by water plus calorimeter. Right, it was the equation. Plug those values and get the equation. Liberated heat by steam. Liberated heat by steam. Right? Absorbed heat by water plus calorimeter. Liberated heat by steam, absorbed heat by water plus calorimeter. Right? Equation याद लिया. Finish. Right, write down below. Calculate. Write down below. Calculate L. Calculate capital L. Calculate capital L. Using the equation. Calculate capital L using the equation. Calculate capital L using the equation. Right? So basically that's it about the experiment. Right? Remarks in a part about the experiment. That's it. Right? May experiments are a method that's the easiest way when you study thermal experiments. Make a set in thermal right? Thermal right? Then make optics and optics theory right? Ray diagrams, ray diagrams, convex lenses, special cases, and especially virtual images in concave lenses. Parts thermal. When you study thermal experiments, the easiest thing is first go through the theory, right? Understand the theory first, right? Theory ka balanna, readings ka balanna, then understand the remarks, right? Ray flow ke giyama very lazy. Theory ka theruna kiyala kiyane calculation ek kamat karana puluwan, but always in the experiment there will be questions about the other things. Why this is done, how this is done, right? Oya questions aana enna goda anne tikata answer karanna overall idea ka thenna one, overall idea ganna mulimma concept එක තේරුණා නම් අර idea එකෙන් 50% නිකන් ඉවරයි 50% නෙමෙයි ඊටත් වැඩි like 60% 65% of the thing is over if you know the logic and the concept here ඊට පස්සේ ඒකට feed කරගන්න තමයි තියෙන්නේ මේකේ එකේ right okay then let's go to remarks right listen in steam generator steam generator ke liye this is only unique this is unique only for this experiment එහෙම ඒවා ඉතින් වෙන මොකද යනවද steam generator එකක් තියෙන අපේ out of all 38 experiments only steam generator we have is the one here right එහෙම unique ඒවා තියෙනවා ඉතින් right listen now when this is heated to 100 degrees celsius then මේ water ඔක්කොම ටික 100 වලට boil කරන්න ඕනේ when it is heated to 100 degrees celsius right what can you say about pressure inside this steam generator does it increase or decrease pressure inside generator steam generator right මේ gas එකත් temperature එක වැඩි කරනවා මෙයත් temperature එක වැඩි කරනවා what about pressure it's approximately a constant volume then when temperature increases pressure increases, right? When pressure increases, there's a risk of exploding this, right? Steam generator එක explode වෙන්න පුළුවන්, right? ගොඩක් අපි heat කරනවා. This is starting from room temperature and heated to 100 degrees Celsius, right? Then there's a risk of exploding this if pressure is excessively increased, right? ඒකට තමයි මෙයා ඉන්නේ. Now, what this is done is, right? See, this is open, glass tube is open, and then from this end, this is open to atmosphere, no? This is open to atmosphere, no? Then, without increasing the pressure inside this, pressure is controlled through this. මෙතන තියෙන්නේ atmospheric pressure නම් දැන් මේකේ මේ හැරෙට එනකම් atmospheric pressure එක ඇවිල්ලානේ තියෙන්නේ. හරිද? Then pressure is controlled using this. Then there's no risk of exploding this even if you heat this beyond 100 even. 100 වලින් උඩට රත්කත් අවුලක් නැහැ. pressure එක වැඩි වෙන්නේ නැහැ. pressure එක වැඩි. ඒ කියන්නේ මේක seal වෙලා තිබිලා pressure එක වැඩි වුණොත් තමයි explode වෙන්නේ. Right? To control it, we have this tube. Right? That's a very popular question, na? ගොඩක් ඒවා අහලා දෙනවා. අයියේ tube එක දාන්න කියලා මතක තියාගන්න ඉතින්. ඒක මේකට විතරක් යුනික් එකක්. Reason is that. Right? නැත්තම් pressure එක increase වෙන එක අපිට control කරන්න බෑ. මෙහෙම වුණාට පස්සේ වැඩේ control. Temperature එක විතරක් increase වුණා නම් අපිට ඇදිනේ. pressure එක ඕනේ නැහැනේ. The actual thing is that even though I need to increase temperature here, if this was sealed, pressure automatically increases. But I don't need to increase pressure. Right? A control can now use karna. Right. First point. The glass tube is used. The glass tube is used. The glass tube is used. The glass tube is used to control pressure. To control pressure inside steam generator. To control pressure inside steam generator. To eliminate the risk of exploding it when heated. To eliminate the risk of exploding it when heated. Right? Next point. Heat losses to environment. By conduction, convection and radiation. By conduction, convection and radiation should be minimized as mentioned before. Right? අර කලින් කියපු ටිකම තමයි යෝදේ. Should be minimized as mentioned before. Right? Next one. Heat compensation method is used. Heat compensation method is used to minimize the error caused due to transfer of heat with environment. Right. Next point. A heat insulated sheet is used. A heat insulated sheet is used to prevent direct heat from Bunsen burner, reaching calorimeter. Right. Listen, this is a good point. Listen, what is the boiling point of water? 100, right? 100 is at which pressure? Atmospheric pressure, right? When pressure changes, both boiling points, melting points changes, right? Common change in when pressure decreases, boiling points decreases. It comes down, right? One thermal current when pressure decreases, boiling points decreases. When pressure increases, boiling points, both the boiling points, melting points, both increases. Right? Now, we have to make sure, listen, we have to make sure this stream is doing the state change at 100, no? Right? 100 ki use karana right? If the pressure of a stream which is coming into this is greater than atmospheric pressure, right? Then boiling point won't be exactly 100, it will be deviating from 100. Right? For that, what we do from the setup is, right, this tube, when steam tube bent tube, it should not be immersed in water, because if there is immersed in water, pressure is going to change, right? Water immersed pressure change, right? Water pressure then right? Maybe in the atmospheric pressure, this is also atmospheric pressure, right? So therefore, this cannot be immersed in this one, right? Immerse pressure change, pressure change, pressure change make a capillary make a tube bag. So I think connect to surface tension. If that is immersed, what happens through this capillary tube? What again? Capillary rise. What is capillary rise? Capillary rise pressure change HOG, right? In his eye must then if pressure changes, steam is not going to do the state change at 100, right? Okay, next point, bent tube should be fixed close to water surface, without immersing in water, without immersing in water. Within brackets, if immersed, pressure changes so that boiling point changes. Right. Next point. A shorter connecting tube. Connecting tube के लिए make mang label करे ना है make रहा connecting tube के लिए. A shorter connecting tube. एक label करना तो ना आएगा में but जब मैं explain करना है भाई मैं आ गया. A shorter connecting tube और नन दिया गया. A shorter connecting tube should be used to minimize. A shorter connecting tube should be used to minimize condensing of steam before adding to calorimeter. Right, next point. Make about stream tap. Right, now even though we use a shorter tube, right, there are particles which are already converted into water. Then to segregate water and steam, this stream trap is used, right? Next point, a stream trap is used to is used to steam trap is used to steam trap is used to segregate used to segregate steam trap is used to segregate condensed water and steam right? Within brackets water goes out from outlet water goes out water කියලා කියන්නේ condensed water මොකද මේ water යන විදියක් නෑනේ condensed water ඕන්න එහෙම ලියන්න condensed water goes out from outlet and condensed water goes out from outlet and only steam flows through bent tube and only steam flows through bent tube. Right? Okay. Right. Quickly, let's check what is here. Right? One way to minimize the error due to heat loss is use a polish calorimeter. ඒවා කලින් කිව්වා ඔක්කොම. Right? Cover it with heat insulating ඒ ටික හරි. Right? ඒ method same හොඳ. ඉතින් ඕක අර හැම එකටම පාඩම් කරන්න දෙයක් නැහැ. they are same. Right? කොහෙද යවුවත් එකම answer එක ලියන්න තියෙනවා ඔයාලට. In the compensation method ඒකත් same. Since the amount of steam that collects in the experiment is small, මේක ටිකක් හොඳ point එකක්. Listen, since the amount of steam that collects in the experiment is small, care has to be taken regarding the accuracy of measuring mass. Right? That's why I told you triple beam balance is not used here. Right? පොඩි amount එකක් නෙන්නේ. triple beam balance එකේ least count එක එන්නේ 0.1 grams. 0.1 grams. ඒක මදි. Right? 4 beam එකේ 0.01 grams. That's enough. That's adequate. Right? The compensation method is often referred as method of hurry. Okay, so that's it for 5. Any questions? Any questions? All good. Right? Right? All good. Right. Experiment 6.